Hello, welcome to ZenView Studios Lab. Eric here. So today is a following video. It's the second video about capacitors. I made a small video about the LCR meter I got recently, but I want to go over capacitors, mainly electrolytic capacitors. There's some other failures. Film capacitors fail also, older ones specifically, but one of the biggest deal is with electrolytics. The reason being that it's not so easy sometimes to say if it's good or bad capacitors when their shape is not good, and we'll see it. I will show you in the zoom. It's easy to see if it's bulging and to determine that there is a problem. But sometimes you have capacitors which have no external signs of problems, and in fact then it's only technical measurement that will tell you whether or not the cap is good or not. And since this is one of the things that you, especially in audio, might change very often, and that will also create problems. I just wanted to make this video. Many have been done, and I will put links as to a lot of material that you can find on the web that explains things about capacitors. However, I never found such a very clarified step-by-step approach, and that's what I will try to give a little bit in this video, specifically about electrolytic capacitor. So let's go about it. So you recall that when I did measurement, I didn't change anything of the parameters. You can read 0.6 volt and 1K. 1K. That's interesting. Something that we didn't look at. 390 microfarad. What's a good frequency value to measure that? Meaning what's frequency at which the reactance of the capacitor will not interfere with the measurement. Aha! Let's see if we lower the value. What does it say? Now we're at 100 Hertz. Miracle! We get a dissipation factor that's only 0.06. And the ESR is 275 milliohms. So the ESR is okay, not great, but okay. And the dissipation factor is very good. Aha! Could it be we made the wrong measurement? Sure is. This is what happened. So in fact, even though it's bulgy, even though all the other stuff are good. So this means this overheated. I'm probably right to exchange it, because if it's bulgy and so on, it's taken a shot. The fact is, even if we test it, and I will show you right after, with high voltage, everything is still okay in this capacitor. So I changed it a little bit out of precaution, just to be sure. The 1K measurement has an advantage, I must say. It exaggerates the dissipation factor, okay? So it gives you a clue. This is why I used it. It gives you a clue how is the dissipation factor overall, and it's how good the cap is in terms of its lifespan. This is the judgment I made, and the judgment call is obviously because it's bulgy, but I changed both, okay? And the reason is that the figures are always the same for both. And if you remember, when we checked on board, we found that there were 0.2 dissipation factor always, or 0.25 for the older ones. So in fact, you know, 0.100, as I said, better at that frequency. But this gives you a hint. That's why you want maybe to change the capacitor, because in fact they have lived a life and they're not even though they still function, they might not work anymore at some point in the future. Now let's look at the really bad capacitor. This is the one which was the culprit, which in fact failed completely. Okay, so what do we see here? Here we see 18 microfarad, a dissipation factor of 148. Okay, let's see what's it's 330 microfarad, 35 volt. So the first rule, even though it looks, well, it looks a little bit bulgy, but it looks almost okay. But the first rule is capacitance. Remember, that's the first rule. And let's see at 100 hertz, which is closer to what you should test. Okay, 56 microfarad, 22 ohms. This is dead. That's a real cap that's dead. This one has finished its life. No matter what you do, probably even if you try to reform the cap, we'll go over that in another video. This is dead. There's nothing you can do about it. It's over. But you see, what why I show you this is because the values are so far off from what it should be. It's clear. This is not good. 333, and I get the most I get is 50 microfarad at 100 hertz, which is, you know, if your power supply, this is a good test frequency. This is, it's done. And ESR of 20 ohm means that this will dissipate so much heat. The more resistance you have, series resistance, the more heat. And this is also said to you by the dissipation factor. Okay, here it's moving a little bit, 0.77 dissipation factor. Let's see the other way around. Yeah, it's the capacitor is moving around. Probably the voltage that I'm applying to it is helping the capacitor, because it's a small voltage. It's even helping him maybe a little. Anyway, it's the 19 ohm that will ESR that's a given that this is finished. Okay, so this is all in all to tell you that even these caps that we thought were bad, but we never looked at the correspondence between capacitance and frequency measurement. And one of the key points is the lower the value of the higher the frequency. The higher the value of the capacitor, the lower the frequency. Aha! So this means 4,700. So it's a low value frequency I should use, like 100 hertz. What do I get? 3,800 microfarad. Okay, it's off by 25% or something like this. So this is still quite not good. 120 milliohm though, so the ESR is okay, and the dissipation factor at that frequency is only 0.29, very far off from the 1 point something that we measured before. So this is not as bad, but this is still quite leaky probably. Again, key element, even though it's not nothing, it's the 25% off from the value. Probably this is on its way. This is the judgment call that you have to make. This is why I spent so much time with other caps and so on, because you have to make always a judgment call as to whether you keep the caps or not. Don't forget you have the unit and the repair, and when you're dealing, so you have to make a trade-off between whether you change or not the caps, if it's a good reason or not a good reason. Recapping for nothing is nonsense, anyway for me, and it's counterproductive. You should only recap when it's needed, and when you see differences, like this one. This one is dead, there's no question. Okay, next we'll go to the dielectric test of a capacitor.